SimCenter FlowEFD is a front-loading CFD tool that is fully embedded in the most popular CAD programs such as Siemens NX, Solid Edge, PTC Creo and CATIA V5, and integrates with your CAD geometry. In this video, we will be looking at a radiator which can be found in many automotive applications. Here we can see the FlowEFD tab and ribbon bar in Siemens NX. In the FlowEFD tree, all our pre- and post-processing settings are defined. The Check Geometry tool shows the corresponding automatically detected fluid domain of the coolant. In the first part of our example, we will have a look at the internal cooling water flow behavior. The wizard can be used to create a new project, define the initial conditions and basic settings such as unit system, applied physical options and more. The inlet and outlet boundary conditions are applied here at the inlet and outlet lid. The goals are defined. In this example, the cooling water pressure drop for this radiator. Once the project has been solved, we can proceed with post-processing. Several post-processing features allow us to investigate the results. The surface plot velocity shows the flow distribution through the different channels of the radiator. As we can see here from the color gradients, there are channels with lower flow velocity shown in blue and channels with higher velocity visible in red. The flow trajectories, visualized here as spheres, also illustrates the 3D fluid flow. We can use the two-dimensional cut plot to analyze the flow through the different channels. Surface parameters are based on the previously defined cut plot, and we can show the mass flow rate through each of the channels. Here, for example, are 3 of these. Of course, we can also export these results to Microsoft Excel. In the second part of this example, we will have a look at the external analysis including the rotating fans. A rotating region is defined for the fan. FlowEFD applies rotating geometry for this region. This means that the rotating fan sucks the air through the radiator. The time-dependent pressure variations for previously defined specific points within the fluid domain are shown here. The radial velocity of the fan surfaces is shown as a transient animation using the Transient Explorer. The fast Fourier transformation allows to convert the time signal to the complex frequency domain. Here we can see the time-dependent pressure plots, which can then be represented in a sound pressure level frequency plot, or FFT plot. In the third part of this example, we will have a look at a combined simulation of the internal and external domain. We apply a fluid subdomain for the water circuit. The ambient initial fluid is air. As shown also in the previous section, here we define the rotating region for the fan. And in this case, we have also assigned the solid materials to take into account the heat conduction. Again, here we can see the water inlet and outlet boundary conditions. And finally, a porous medium is defined as a surrogate material for the radiator fins. This porous media takes into account pressure drop and heat transfer as a function of the velocity. Let's have a look at the results. This cut plot shows the air velocity, and the surface plots show the temperature of the solids and the water temperature. Finally, here's a view of the flow trajectories for the internal coolant and for the external air. Of course, several post-processing features allow us to investigate specific areas in detail. These investigations can be carried out very efficiently by the design engineer with FlowEFD embedded in your CAD system, shown here in Siemens NX. But FlowEFD also offers the same level of integration in PTC Creo, CATIA V5 and Siemens NX. Thank you for watching this video. For more information, please visit our website.